In this video, we are going to study the concept of differentials. Differential is derived from the word difference. That means we are going to study the difference in y values. But before that, let us see what's the difference between linear approximation and differentials, how they are similar to each other and how they are different to each other. Linear approximation is used to approximate the value of function, whereas differentials are used to study the change in y values corresponding to change in x values. They are similar as well because they both use the concept of derivative. In our previous video, we learned how we use linear approximation to approximate the value of function, and you can find the link of that video in the description box. As we said, for differentials, we deal with change in x values as well as change in y values. Here, delta y is used to represent change in y values and delta x is used to represent change in x values. Before going further, let us see what's the difference between dy and delta y. They both represent change in y values, but how they are different. Delta y is the true difference between y values of the actual function, whereas dy is the difference in y values of the tangent line corresponding to the difference in x values near a specific point. So let us understand this concept using this picture. Let us say this point of contact is x1 and this is x2. Delta x represent the change in x values, x2 minus x1, and this one is the corresponding y value, and this is y2, which is the y value corresponding to the x value x2. So we can see here that delta y is the difference in y values, y2 minus y1, of the actual function fx, whereas dy is the change in y values of the tangent line. This tangent line is drawn at the point x1. This is the point of contact x1, y1. This one represents dy. So dy is the change in y values of the tangent line. So when this difference in x values is made small, we make it smaller and smaller, and when it is very small, then this difference in y values, delta y, is nearly equal to dy, and dy over dx can be represented as limit delta y over delta x when delta x is approaching to 0. That means this difference in x values is very small, then delta y behaves like dy. Let us understand this concept more. It says to use differential to estimate change in volume of a sphere when its radius is 10 cm and dr, the change in radius, is 0.01 cm. Let's find delta y, the difference in y values of the true function. So here we have r1 as 10 cm. Difference in r values is 0.01 centimeter. So if first value is 10 centimeter, the next value would be 10.01 centimeter. We need to find the difference in y values corresponding to these r values. First we write the formula for volume of a sphere. So we are going to study the change in v values when the r values are changed from 10 centimeter to 10.01. First we find v1. For that, we just plug in r as 10, calculate its value. It's 4000 over 3 pi. Then we find the second y value when r is 10.01. By subtracting them, we get the difference in v value, which is approximately. So this was the true change in y values of the actual function. Next, we are going to find the change in v values, dv. For that, we are going to use derivatives. We find the derivative of the volume function with respect to r. So that is dv over dr equals 4 over 3 pi times 3r square. After simplifying, we get pi r square, and then this dr get multiplied on the other side, 4 pi r square times dr. Now we are going to plug in the values of r and dr. .566. Now we can see that both these differences, delta v and dv, they are nearly equal to each other. A very small difference between the two, that is called the error. This change in values of delta v and dv is called the error in approximation. When the difference in input values is very small, then the difference in delta v and dv becomes very small, almost negligible, and in that case dV is approximately equals to delta V or very small changes, and that's why we write it as the limit delta R approaching to 0, delta V over delta R is nearly equal to dV over dr. In this next example, we need to find the approximate area and the percentage error in the area of pizza. So first we are given the radius as half of the diameter, which is 7 inches. Here we are given the accuracy of 2%. That means the change in R values is 2% of 7. So dr is 2% of 7, which is 0.02 times 7, which is 0.14. Now we can find the change in area dA. For that, we are going to use the area formula of a circle, and now we are going to use differentials. We find the derivative of A with respect to R, so it's pi times 2R, and multiply dr on the other side, it gives you 2 pi r dr. Now we plug in the values of R and dr, we get the approximate value as 6.16, and then we find the actual area, pi times 7 square. We need this area value to get the percentage error, and we get this value as 153.94. The percentage error is given as dA over A times 100, and we get the percentage error as 4.001, which is nearly equal to 4%. For this next example, we need to identify what we are given and what we need to find. So here we are given the circumference as 84 and the error in circumference is 0.5 centimeters. So this is delta C, the change in circumference. We are going to use the formula for the circumference, 2 pi r. Now we take the derivative of both sides. The derivative of C is dC. So dC is given 0.5 pi dr, and the value of dr is 0.5 over 2 pi. Here we need to find the maximum error in surface area. That means we are going to use the formula for surface area, 4 pi r square. We don't have any value of r given here, but we can find the value of r using the given value of C, the circumference. We can say this is step 1. In step 2, we can find the value of r using the circumference value. C was given 84 equals to pi r, so 42 over pi is the r value. At last, we need to find the change in surface area, the error in surface area. So this is going to be the third step. Change in surface area is given by dA, so we find the derivative of both sides. R is 42 over pi times dr is 0.5. After simplifying, we get 84 over pi, which is nearly equal to. So this is the error in surface area. This is how differentials are used to find the change in y values when there is any change in inputs, the x values, and how they are used to approximate the percentage errors.